Dear students, I Prakash Birla, Assistant Professor, Textile Technology Department, MLB Textile and Engineering College, Bhilwara. Today, in this video lecture, I will discuss about the polyethylene, the polyethylene terephthalate, the polyester, and polyester is the one of the most popular synthetic fiber and most widely used in the apparel as well as home textile and in other industrial applications. Amongst the all synthetic fiber, polyester is the maximum, or you can say the number one spot in the total consumption of all synthetic fibers together. Even it surpasses the in the total consumption, and nowadays it is more than consumed by the cotton even in modern world. Because of various technology, it helps in the various technological developments. It is possible due to various technological developments. Now, what is polyester? Polyester is defined as a manufactured fiber in which the fiber forming substance is any long chain synthetic polymer which is composed of at least 85% by an ester linkages, which is made of or composed of or manufactured by the reaction between the diglycols and terephthalic acid. You can see in this diagram or here the repeating unit of the polyester, that is R dash C double bond O single bond O, again connected to the R dash. It is a polyester in which one of the R is the aliphatic group and another R is the benzene ring, and you can see here what is the chemical nature. Polyester fiber are synthetic textile fiber of high polymers which are obtained by the esterification of dicarboxylic acids with the glycols, that is dichrone, or by ester exchange, or you can say the trans-esterification reaction, that is terylene reaction is carried out between the dicarboxylic esters and the glycol. Now first the terylene. The terylene is discovered in UK, United Kingdom, and it is manufactured or made by polymerization of ester interchange or ester exchange reaction, which is carried out between the dimethyl terephthalate and the ethylene glycol. DMT, that is the dimethyl terephthalate, and EZ ethylene glycol react with one another at particular with the help of a catalyst and specified temperature and pressure conditions. In the total time of reaction may vary, depends on the catalyst and the compound containing at the start of reaction, and PET, the polyethylene terephthalate results, which is another is the important development in the polyester that was produced by the help of terephthalic acid directly, that is the dacron. It is made by the polymerization reaction using terephthalic acid and ethylene glycol, that is, you can see here terephthalic acid reacts with the ethylene glycol and results in the polyester, and is the difference between this terylene and dacron. Dacron is produced in the US and it is different than terylene. How? And from the above both equations, the terylene and dacron are essentially the same, and that the only they differ in that the former means that terylene contains a methyl ester group at one of the end of the macromolecule, and the latter contains an acid group instead of that. So this is the basic difference between the two type of polyester. One is the terylene and another is the dacron. In dacron, acid group is there at the end, one of the end, and in the terylene at one of the end is methyl ester group. Now how it is synthesized? The synthesis of monomer means the raw material preparation. The raw materials for the polyester fibers will be ethylene glycol or terephthalic acid or dimethyl terephthalate. Manufacture of ethylene glycol may be made by the direct hydration of ethylene oxide, and ethylene oxide can be produced by the two methods. Yes, first the preparation of the ethylene glycol, and it is carried out with the help of ethylene glycol, or ethylene glycol is manufactured by the hydration of ethylene oxide. Ethylene oxide can be prepared by the chlorine process or by direct oxidation. You can see here in the chlorine process, the ethylene gas, by the petroleum cracking, the pure ethylene gas is separated and it is reacted with the hypochlorous acid, and this hypochlorous acid get converted into the chloroethanol. Yes, hypochlorous acid can be produced by the reaction between the water and chlorine gas. Means the chlorine gas is passing through a water and get converted into hypochlorous acid. This hypochlorous acid react with the ethylene gas and convert into chloroethanol. Now this chloroethanol is passing through, or you can say react with the calcium hydroxide, that is 5% solution of milk lime at 100 degree centigrade temperature, and convert into ethylene oxide, and the calcium chloride is precipitates at the ground. This ethylene oxide, a gaseous matter, you can see here, go for the conversion to the ethylene glycol. Now the ethylene oxide can be produced by the another approach, that is the direct process. An ethylene oxide, ethylene and oxygen mixture is passing through a tube having silver catalyst with an inert base. The reaction is carried out between these two at 200 to 240 degrees centigrade, and the yield will be about 60%. Means the 60% ethylene gas get converted into the ethylene oxide at high temperature of 200 to 240 degrees centigrade. Silver is used as a catalyst. Now this glycol from the ethylene oxide, yes, ethylene oxide is hydrated at 60 to 70 degrees centigrade temperature at in presence of acid and get converted into ethylene glycol. Now for the polyester production, it is important to maintain the standard, or you can say the specification, recommended specification for the purity of ethylene glycol. The quality of polyester polymer depends upon the purity of ethylene glycol. It is important. So that's why for the purity it must fulfill following requirements, or you can say, and give its external appearance must be transparent and a white clear liquid. Its boiling point is 195 degree to 198 degree centigrade. Density of the ethylene glycol is recommended for this. It is 1.12 gram per cc. Water content, it must be below than 0.1%. Refractive index, it is around 1.433 to 1.434, the refractive index of the ethylene glycol, and it's above all these, and its resultant means the ester interchange value, how faster it effectively change into the ester, that is the ester interchange value, it must be above 90%. So this is the one of the important raw material of the polyester, that is the ethylene glycol, and its purified condition says that in the coming lecture I will use this for the ethylene glycol. In place of ethylene glycol, I will use the monoethylene glycol as a raw material for the production of polyester. Thank you. I will give more detail more about the polyester in the next lecture for the raw material preparation of polyester. Thank you.